It is 2 in the morning somewhere in the North Pacific. A container ship the length of 3 football fields pushes through a Force 8 swell. On deck, 40-foot steel boxes are stacked 6 high, lashed against seas already cresting above the rail. Then one stack shifts. The lashings go, and a container, 28 tons of sealed cargo, goes over the side and disappears into black water. No alarm sounds on the bridge. No recovery crew scrambles. The ship does not stop. By morning, there is no trace. The official global estimate runs around 1,000 containers lost at sea every year. The real number is almost certainly higher. What happens next is nothing like what most people assume. The obvious picture writes itself. Steel box, dense cargo, cold deep ocean, it sinks. Fast, straight to the bottom of the ocean. Done for. Except, that's not what really happens. Many lost containers do not sink at all, at least not for days, and sometimes not for weeks. Sealed goods trap air inside. Foam packaging resists compression. Expanded polystyrene, sneakers, sealed plastics, all of it fights waterlogging far longer than the steel exterior around it suggests. So the container does not go to the bottom. It drifts, pushed by wind, moved by current, slowly waterlogging from the bottom up while the top stays sealed. And here is where it becomes dangerous in a way most people never consider. A container riding 30 centimeters below the surface is essentially invisible. It does not register on standard navigation radar, which is calibrated to detect objects with significant surface area above the waterline. It does not reflect light at night. It sits just deep enough to disappear from every detection system a ship relies on, and just shallow enough to destroy anything that hits it at speed. A modern container ship travels at around 20 knots. At that speed, a collision with a semi-submerged steel box is not a glancing blow. It is a point-load impact, the full kinetic energy of a vessel that may weigh 50,000 tons or more, concentrated into a contact patch the size of a corner fitting. Most commercial hulls are not engineered to absorb that. Bulkheads can fail, compartments flood. There are documented cases of vessels taking on water after container strikes at sea and smaller commercial craft, fishing boats, yachts, coastal ferries that simply never made it back to port. The incident reports that do exist describe hull breaches that gave crews minutes, not hours. The maritime insurance industry has a phrase for all of this: shipping casualty. 2 words that can cover everything from a crumpled bowplate to a vessel going down with crew aboard. The language is deliberately broad. It has to be because the causes are often never confirmed, and the physical evidence is usually sitting 4 kilometers down on the ocean floor. Here is the counterintuitive part. The containers that sink fast are actually the safe ones. A box that drops straight to the bottom in deep water presents 0 navigational hazard to any ship that follows. It is simply gone. The dangerous containers are the neutrally buoyant drifters. Too deep to see from a bridge watch, too shallow to pass safely under a keel, moving steadily through the water column as they take on ballast from below. And they move far. An empty or lightly loaded container can travel more than 1,000 miles before it finally takes on enough water to go under. The cargo inside determines the timeline entirely. A container full of sealed electronics might stay afloat for 2 weeks. A container of compressed foam products might last longer. A container packed with rubber ducks, it turns out, can stay afloat for years. That is not a metaphor. In 1992, a cargo ship crossing the North Pacific lost a container holding nearly 30,000 plastic bath toys, yellow ducks, red beavers, green frogs, blue turtles. The container split open in rough weather and the toys scattered across the surface. Oceanographers began tracking where they went. Over the following 15 years, those toys turned up on beaches in Alaska, in Japan, in Scotland, and eventually in Maine. They traced the full circulation of the Pacific Gyre with more precision than most purpose-built research programs had achieved. They confirmed that objects entering the ocean at the wrong place do not disappear. They orbit. That single container loss, an accident, a rounding error in annual shipping statistics, became one of the most consequential drift datasets in modern oceanographic research. Now scale that up. Global container shipping moves somewhere around 800 million container loads a year. 1,000 annual losses sounds negligible against that volume, but those containers are not distributed evenly, and they do not sink into empty deep water. They fall near shipping lanes. They fall near coastlines. They fall near reef systems and fishing grounds and the approaches to major ports where traffic is densest, and the margin for deviation is smallest, and the ocean floor near high-traffic straits is not flat and clean. Deep-sea ROV surveys have found container fields on the seabed, boxes stacked and scattered in patterns that follow historical trade routes, like a map drawn in wreckage. Some of those containers have been down there for decades. Those are only the ones anyone has bothered to look for. The reason the real annual loss number is almost certainly higher than official estimates is structural, not accidental. When a container goes overboard, the operator is legally required to report it to maritime authorities. But reporting triggers investigation. Investigation can mean port delays, insurance audits, and potential liability for cargo damage and navigational hazard to other vessels. The incentive structure points directly away from honest disclosure. The IMO, the International Maritime Organization, mandates the reporting. It cannot enforce that mandate on the open ocean at 2 a.m. in a Force 8 swell. There is no satellite system that independently tracks individual containers after they leave port. There is no automatic detection when one goes over the rail in the dark. The system depends entirely on voluntary reporting from the party most motivated to stay quiet. It is an accountability framework built on a foundation of assumed good faith, which creates a behavioral paradox that stops most people cold when they first hear it. When a container goes over the side in heavy weather, the correct operational response, the one trained officers follow, the one safety protocols mandate, is to not attempt recovery. Do not turn the ship around. Do not slow into the swell. Log the GPS coordinates, note the heading and speed, transmit the report to maritime traffic control, and continue the voyage. To anyone watching from the outside, this looks like abandonment. It looks exactly wrong. But turning a vessel of that size and displacement in heavy weather generates a list risk that can destabilize the entire ship. The container in the water is already a hazard. A floundering vessel trying to recover it is a far worse one. The correct answer is to leave it, report it, and trust that a maritime hazard alert goes out to other traffic in the area. The paradox is that this system only works if the report is actually made, and the report is made by the party with the strongest reason not to make it. The regulatory pressure that eventually tightened container lashing and loss reporting standards did not come from a single catastrophic event. It came from something slower and harder to dramatize: the accumulation of invisible losses quietly landing on insurers' balance sheets through the 2000s, building until the numbers became impossible to ignore. The MSC Napoli grounding in 2007 off the Devon coast gave the problem a public face. Containers washing onto English beaches, branded cargo being looted by crowds, a sudden visible demonstration of how little accountability existed for individual containers post-loss. The MV Oliva ran aground near Nightingale Island in 2011, and its cargo obliterated one of the most isolated penguin colonies on Earth. Neither event alone forced the change. Together, and alongside the financial data accumulating in underwriting departments, they produced the updated CTU code, tightened lashing requirements for deck cargo that had not been seriously revised in decades. Not because regulators suddenly understood physics differently, because the cost of not changing had finally become quantifiable. Here is what all of that looks like in the physical world. Those metal fittings running along the deck rails of a container ship are not structural framing elements. They are lashing anchor points, the primary mechanical system standing between a fully loaded stack and open water. The twist locks connecting stacked containers at each corner fitting, 4 per junction, are what transfer dynamic load between boxes in a rolling swell. When one fails under cyclic stress, the load redistributes onto the remaining 3. The failure propagates. That is not a theory about edge cases. It is the documented mechanism behind most deck cargo losses in heavy weather. and the rust staining on the lower hull of older vessels, the kind that bleeds orange through the anti-fouling paint below the waterline, is not always simple corrosion. Some of it is contact scarring. The ocean records what happens to these ships, even when the operators do not. The messier reality is that not every container loss is an accident. In genuine stability emergencies, deliberate jettison of deck cargo is both legal and operationally documented. It is a last resort, but it happens, and when it does, the paperwork often lags well behind the event. When the jettisoned container holds dangerous goods like lithium batteries, compressed industrial gas, and chemical precursors, it does not simply become a navigational hazard. It becomes a slow-release contamination event sitting on a seabed near active fishing grounds or a shipping lane used by thousands of vessels a year. Some insurers now require active GPS beacons on dangerous goods containers. The cost of those beacons, modest in absolute terms, a few $100s against the value of a loaded container, is still being resisted by operators running on margins measured in fractions of a percent per voyage. The economics of scale make the resistance rational. That is what makes it persistent. Every container moving through the global system carries an IMO number stamped permanently on its side. That number traces back to a manufacturer, a registered owner, a shipper, and a detailed cargo manifest. The tracking architecture around that number while a container is aboard a vessel is reasonably solid. Port logs, customs declarations, weight certifications, manifest records that follow it from origin to destination. The tracking architecture for that same number the moment it goes over the rail in the middle of the North Pacific at 2 in the morning is essentially nothing. No beacon pings, no satellite handshake, no automated flag in any system anywhere. The container simply exits the network. The bath toys from 1992 are, statistically, still out there somewhere, waterlogged and bleached, turning slow circles in a gyre that does not care about cargo manifests, insurance classifications, or the gap between what the system promises and what it actually delivers. The lost container problem is not a gap in the system. It is a feature of a system built for throughput, not accountability. 800 million moves a year, optimized for speed and volume, with loss rates small enough to stay buried in the rounding until they become someone's ecological disaster or someone's hull breach in the dark. The ocean floor near the world's busiest shipping lanes is not empty. It is an archive of every calculation that went the wrong way, visible only to the ROVs that occasionally descend to find boxes sitting exactly where the trade routes say they should be. And that IMO number, permanent, traceable, theoretically connected to every kilogram sealed inside, raises a question that goes well past navigation hazards and drift research. Because if the tracking disappears the moment a container hits the water, the reasonable follow-on question is how precisely anyone knows what is inside the ones that stay on board. The global container system moves around 200 million fully loaded boxes every year. The physical inspection rate at most major ports runs somewhere between 2 and 10%. The math on what passes through unexamined is not a small number.